The purpose of this video is to check over worksheet 32, solving one-step inequalities. There's nothing to check on page 1, which would be the front side, because I did 2 and then we did 2 together through the Edpuzzle video, and the other ones that you were taking care of on your own are on the second page. For number 1, what's being done to the variable, it's touching with 6, and when they touch, that means multiplication. What's being done on number 2 is subtracting 4 from h, dividing by -6. Here, 5 is being added onto t, the variable. Here the x is being divided by -4. And here, 5 is being subtracted from p. Now I'll make my plan of how to undo, which is the inverse of all of these operations. The inverse of multiplying by 6 is dividing by 6. The inverse of subtracting 4 is adding 4. The inverse of dividing by -6 is multiplying by -6. The inverse of adding 5 is subtracting 5. The inverse of dividing by -4 is multiplying by -4. The inverse of subtracting 5 is adding 5. And I'm going to go through and see if any of these will flip. If they multiply or divide by negatives, you saw in your Desmos activity with the emojis, you got a wrong answer, and you have to flip the inequality symbol to avoid that. Don't see any multiplying or dividing by negatives there. This one doesn't even have multiplying or dividing. This one has multiplying or dividing by negatives. I'm going to set up my symbol ahead of time. I don't want to forget about that. No multiplying or dividing at all, let alone negatives. Here, this one has multiplying or dividing by negatives. So this symbol will need to be inverted. Now I'll go through and I'll show my algebra work on everything. The plan is to divide by 6. The plan is to add 4. The plan is to multiply by -6. To subtract 5. To multiply by -4, to add 5. I'm left with my x isolated, and 12 divided by 6 is 2. So my solution is x's that are less than 2. H is isolated. 9 plus 4 is 13. X is isolated. 11 times -6 is -66. T is isolated. 14 minus 5 is 9. X is isolated. 3 times -4 is -12. P is isolated. 4 plus 5 is 9. Now I'm going to make a number line graph of all of my solutions. I like to put my solution in the middle because I really like symmetry, but you can put your number anywhere. I also like using a scale of 1. I like my values to increase and decrease by 1. However, you can use whatever scale you want. Your number line is not being judged on the scale. Your number line is being judged with open circle or closed circle, arrow to the left, arrow to the right. Okay, for number 1, my answer is x's that are less than 2. The less than sign means an open circle, and values get less as you go to the left. The 2 is not included, so I'm not shading it in. H's are greater than 13. The greater than sign has an open circle. It does not include 13. It just says greater than 13. And values get greater when you go to the right. X's that are less than negative 66. The less than sign has an open circle, and values get less as you go to the left. T is less than or equal to 9. This circle will be closed in because of the equal to part of that symbol. That means that 9 is included. But less than still goes to the left. X's less than or equal, closed circle. P's that are greater than 9. Open circle at 9. And values that are greater. Now I'm going to use my number lines to check my work. You can pick anything from the shaded region. I usually just pick the next closest number. I'm going to use a 1. You can use any number less than 2. We don't have to pick the same number. That's the beauty of solving an inequality, is you get a little bit of checking freedom. As long as you choose a value in the shaded region, you're fine. So for the first one, the x that's less than 2 that I'm going to pick is a 1. 1 is less than 2. 6 times 1 is 6, and then my statement is 6 is less than 12. That's true. So I know that I correctly picked a number less than 2. For the second one, I'm going to pick 14 because I needed an h that was greater than 13. And the statement that I get is 10 is greater than 9. That's true also. So I'm feeling pretty confident about my answer. I need an x that is less than negative 66 for number 3. And I picked negative 72. And if you're thinking, Miss Halpern, why'd you pick something so far away? Shouldn't you have picked negative 67 if that's what you like to do? I also want a number that I can easily divide by 6. And I know that 72 is divisible by 6 and I would get 12. They're the same sign, so it's a positive 12. And now my statement is 12 is greater than 11, and that's true. So I do like to pick the next closest whole number or the next closest integer, but also if I see I have to divide, I try to pick something that's easily divisible by that number just to avoid decimals. I'm trying to do quick mental math when I do these. Now I need a t that is less than or equal to 9. I'm going to pick 8. That's less than or equal to 9. 8 plus 5 is 13, and then my statement is 13 is less than or equal to 14, and that's true. For number 5, I need an x that is less than or equal to negative 12. I'm going to have to divide it by negative 4. So I just picked 16 because I know that 16 is easily divisible by 4. Negative 16 divided by negative 4 would be a positive 4 because they are the same sign. And then I get 4 is greater than or equal to 3, and that's true. Finally, I need a p that is greater than 9. I just picked 10. And my statement is 5 is greater than 4. That's a true statement, so I feel good about picking a p that was greater than 9. When you see your grade is based off of certain components. First, your do-undo. Secondly, the algebra solving work that you see in orange. Third, the answer. Fourth, the graph. And fifth, the checking. So each one has 5 checks times 6 problems. That would make 30 checks. and these are about 3 points each. So if you see a score, that's where the score came from.